的事务所在台湾也有分公司，所以他们也都会在台湾招员工。之前手上有好几位同学也是在头大上这事务所在工作过，所以应该说丰田老师跟台湾非常的亲近啊，我们非常多的案子这一次只是因为疫情的关系，好多年没有回来，所以特别邀请丰田老师回来跟大家分享。那今天这个主题啊，就是其实延续上礼拜那个伊达老师来的跟 informatics 这个像建筑资讯学也是有关系的。那只不过丰田老师跟那个伊达老师在处理的这个资讯学又有点不一样。那丰田老师跟产业就有非常多关系，而且跟文化创意产业。那还有在处理跟实务建筑专案跟实务有非常多的这个实例跟这个连接啊。等一下就看到很多的专案，大家都看到。所以等一下你们在看这些专案，你可以想一下，就是未来等于说丰田老师在秀给大家看的，其实也是未来各位有可能会碰到的建筑专案在执行的时候的一种可能。那只不过丰田老师他们现在已经在做了，已经很实务性的在做这个事情。但在台湾可能没有那么快，但是那就是一个可能的未来。那如果各位有什么样的想法，等一下就可以尽量去提问，可以想想看，实际在执行上面，或者是对里面的一些涉猎的领域，因为涉猎领域非常广，可以多去问。好，那接下来就交给这个Toyoda老师，欢迎Toyoda老师。
Okay, thank you very much for your introduction, even though I didn't understand, but sorry that I have to speak in English and I hope you're fine with it. And it's so glad to be back here. I used to be assistant professor here for, I don't know, 3-4 years. I was constantly teaching a studio. And after COVID, I had to stop it and then stop coming to Taiwan. And I got I am a practicing architect and not the academic field person, but I took a position at the University of Tokyo now, fully teaching there too. So I can take the other jobs, the teaching job abroad. So it's been away for more than 6 years, and I'm glad to be here, and nothing that much change. And so I'd like to talk about the architecture practice at our office called NOIZ, and also our research. Sorry that my throat is kind of dry, so I might be coughing a little bit sometime. But the common ground, which is the research theme of our laboratory at the University of Tokyo. I would start with the practice that our NOIZ office is called NOIZ, N-O-I-Z, and so. Anyway, we have a small office in Tokyo. We have a main office in Tokyo and a small office in Taipei. So, and we've been doing the projects, Japan, Taiwan, some Asian countries, and then also the US, and then sometime in Europe. So try to be a little, as much as possible international. But since COVID, we've been kind of retreating within Japan, but then now the time is right, and we are expanding out too. And to start with our introduction or project, the first thing I'd like to talk about is the Expo 2025, which was held in Osaka. Does anybody had the chance to go to Osaka during the Expo and then seeing it? Oh, wow, quite a ratio. That's great. Thank you very much. Yeah, I was the venue designer in the bidding process up to when the Osaka won the bidding. That we were competing against Paris and Baku and Ekaterinburg, and there was one more. But anyway, it was practically between Paris and Osaka, and we won. And then I was the venue designer up to we won. And this was the venue design. Back then, as you might know, that the huge ring, that wasn't there. That's a So Fujimoto's addition. Our design was, the theme was dispersion and decentralization. So it's more like how we can integrate the nature of the tech society could be into the the physical urban planning or city structure. So city and architecture, building construction, everything is very solid and physical, and it's contradictory to the let's say digital, the decentralization and then kind of fluidity. But we might need to be able to kind of combine those together so that the city and then urban planning construction might need to have some integration of the that kind of dispersion and fluidity. And this was supposed to be to accommodate with it. It's in a different time scale and different layer, and how the physicality could accommodate the potential fluidity or the kind of movable, kinetic, changeable quality of the urban planning. Expo is a great opportunity because the construction of a city is way too much of the expenses. But this is something, if you win, you have to build a city. And this city is meant to be only half a year. Nobody's going to live there. So, and then it is expected to be experimental kind of city, and everything's going to be demolished afterward. So it's a perfect location to test a potential technology and physicality and also structure for a future society without having any conflict with the resident, which has been the bigger issue for a smart city implementation. I don't know if you're familiar with the Toronto issue with the Google trying to kind of do a lot of investment in Toronto waterfront, and then it's like a tech, friendly tech kind of, hyped future vision, but that was demolished. I mean, the plan was kind of dumped, and that Google has to withdraw because of the resident big resistance to it, because of a human rights issue, because of the personal data issue. And so it's always a conflict between the reality of the residents and the tech expectation. But the expo could be the potential good venue to test both without having the residential, the conflict. But somewhat, so Fujimoto and he is my 2-year senpai and a really good friend, but he completely flipped after my role is done, and he took over the venue design role, and then he introduced the huge ring, which is that centralization and that materialization. So in a way, there's the contrast between those two, and then my theme is mainly about the not one way extreme, but the how to integrate those two, physicality and digitality. So in a way that I'm very happy with the actual result, but at this moment we might have missed the certain quality and certain opportunity too. The bottom layer, physical layer of the venue design, this is important, especially your architect. We have to get a job, we have to be licensed to design something and build something. Construction is the good foundation of the economy, the society. That's very important, but that's not the only thing that we have to deal with. The top layer, digitality, the foundation of the current society lies big time on the digital network. That is, very important foundation as well. But at this moment, we are dealing with or talking about the physical layer and digital layer completely separately. We don't know how to integrate those two as the interface, like in the middle. We call it common ground. And we don't know how to build a digital physical integration interface in the daily life or as a form of a city. So we expected that this expo could be the good experiment to test, to build such a thing and correct the data for such a thing, and get the good result for the future. That might be the legacy of this expo, which that part has missed because of the success of the physicality in a way. And then so again, I was the venue designer up to the bidding process, and after we won the bidding, I shifted to the actual building designer, which is we call it in Japanese nuru-nuru. Nuru-nuru is the null square. In a computational language, null is means nothing, empty, zero. Not really zero, but it's kind of like a philosophical theme and also computational theme. But in Japanese, nuru nuru sounds like a strange for you, but nuru nuru is the term. It's like a, I don't know, fluid, gluey, and like, I don't know, soft and then kind of, melting kind of thing. So that's the atmosphere of it. And this is if for you that they haven't been there, they actually move like this. This is entirely composed by the membrane, specially developed membrane for this project. We spent 1.5 years to develop this material with the Taiwan Kogyo. And then the whole composition, I mean the building, is covered by this membrane. We carefully developed all the edge details and then all the joint and everything, so that it could be composed as material-less feeling as possible. This has a materiality which is a mirror surface, but impractically, in a way, it's a real-time rendering of the natural condition. It catches the sky, it catches the cloud, it catches the surrounding tree and a human being, so that all those becomes its texture. So it's a real-time texture mapping in a way. So it doesn't have any materiality, but it has a function of distort the real circumstance around it. And also it is curved in certain fashion, so it's kind of, the surrounding condition, for instance, middle, there is the distortion flip side. Thank you. For the surrounding condition. So it's an interesting kind of composition that that your perception of the real physical circumstance is not as you understand. So it's just a reflection, but reflection distort the circumstance around you, a world structure around you. So it's going to give you a question. Is the real world, is it really absolute? It might look different day by day, weather by weather, time by time, and then also as you move around, the circumstance constantly changing, right? So it's in the context of the digitality and the physicality. Normally, you would think digital is something. It could be copied and changed, and millions of different conditions could be possible. That's the general understanding. Whereas the physicality is always absolute one right circumstance for anyone. But in a way, the perception of the real space is slightly different for everyone. And it might be different for a dog or cat or turtle or the swallow, anything. Because their eyes are different, insect, it might be different too. And then, any living creature has the different kind of system of perceiving the information from the world around you. That means that the world structure for everyone is different based on the functionality and the data format of you process the circumstances. So that's called unbuilt, or the world model, whatever. There is a hot topic around it. So that the physicality doesn't mean it's absolute right one world around you. So this is the suggestion that the world around you is not like you can completely rely on as the absolute kind of circumstance. And the digitality is not like a contradictory, binary item, but it's more seamless continuation between physical, real, or digital, right? And inside is the completely digital space. And then I don't have a picture here, but it's a contrast, but the seamless continuation between physical and real and digital. It's nice that they capture the different portion of the sky. So it's especially in the sunset or in the morning, the gradation is disturbed and recomposed into this kind of combination, because the voxels are composed in this very random fashion. And sometimes it's distorting. And so, that it automatically decomposes the physical circumstance around you. And on top of it, there's sometimes it look like it give you an illusion that it's actually floating in the air, And this is a composition. This is 1 meter, 2 meter, 4 meter, 8 meter kind of a cubic unit, which is called voxels. It's kind of association with the Minecraft, which is the kind of general shared experience from your generation, I guess. So it's digital experience and physical experience are all combined, and etc. etc. And this is the actual drawing, inside experience and outside and stuff. And this is a movie that it's showing the distortion. We put quite a few different type of the actuator inside the building, taking advantage of the softness of the building. So this is the example that the robotic arm is inside, it's pulling and pushing and then twisting to distort the surface. And this is the combination of a robotic arm and also the speaker inside. The speaker is making a super low sound that vibrate the surface. So if you change the frequency of the speaker, and then the wave pattern changes. So in a way, this form is generated by the sound, and it's constantly changing. And the building rolls. So it's also give you a kind of feeling that the building is almost alive. So, but it's not like as intelligent as a human or robot. It's super primitive. So it's just a borderline that it's alive or not. So we call it as agenciness or agentification, giving some agentness to the building. We normally think architecture, circumstance, city is the dead and still structure. And we as a human or the robot or the animal as the agent, but maybe building could be agent. And what's the threshold between? Actually, it's not that clear. And we're trying to suggest that the building could be an agent to a certain degree, but there is a gradation. So this is the woofer, and also natural sound and natural wind also makes the vibration. It's kind of nice that the digitality and the physicality also combine and constantly changing the impression of the building. So currently one of the main kind of interest that we have in the design and architecture as an agent. This is one of the examples. It's like almost 10 years ago, we had to design a tiny window, show window for Bao. Do you know this brand? It's Issei Miyake's kind of conceptual brand with the triangular pattern. Yeah. So they somehow ask us to use this flexible, elastic LED screen, which for no reason, but we have to use it. And it happened to be Bao logo, and then this resolution matches very well. So we use the Bao logo on it, and maybe you're familiar with the concept of a Conway's game of life, the most simple kind of automatic cellular automaton pattern. And so we apply to this. So Bao logo self kind of changing constantly like amoeba, but we put the fan, physical fan underneath. And sometime at the random timing, fan turns on and that blows the air, and that makes the this membrane wobble. And then what we try to achieve is that of course the digital pattern on the LED is the pure information. It's not physicality, but the wind is very physical thing, and the wind has nothing to do with the information, but we plan it very carefully so that once the wind blows, we run the physical simulation on the pattern, so it blows away. And then the result is you somehow feel the haptic quality to the digital information. That's actually formed in your brain, but that's something that we try to achieve so that the digitality information could have some kind of materiality. Another example, this is in Taipei. It's a public art project, and we work with the name is wrong. It's actually work with the YIXD, which is a Taiwanese digital team, and also the sound artist, Kazuhiro Joe. This is the actual credit, NOIZ and Joe Kazuhiro and YIXD. And this is something that we did the kinetic pattern of the facade of the building. And it doesn't need to be, it's a public art. but we try to communicate different layer of information between different agents, different part of the city. What we're doing is we take the sound of the street, garbage collection car, whatever, and correction, or whatever who is chatting, that sound is taken, and that could be transformed into the grid matrix on and off. And that could be translated in certain logic into this pattern. And this pattern, again, common with game of life, could regenerate the sequential kind of change of the pattern too. And then after that, after certain timing, another new pattern is generated. And that new pattern could be same logic regenerating back to the sound. And that could be projected into the street. So in a way, the street and the building start communicating through the sound and pattern, right? So it doesn't mean anything for us, but in a way, it's interesting in showing the possibility of digital technology. They can translate totally different language, totally different type of information. It's a kind of unnecessary kind of huge device behind, but that's an interesting thing. It could be transferred anything. If you can, let's say, I don't know, your temperature could be taken and that could be applied to the lighting, or I don't know, your boredness, or I don't know, the sleepiness could be translated into something. Anything could be, done because as if that could be taken as the digital information. So we doesn't need to be limited to the start with the form and end with the form. It could, but we can use some other methodology and different information. So, and then also that type of thing could be applied to some other experimental project. And this is one of the project we did 2 years ago, collaboration with the Bandai Namco and the Daiwa House in Tokyo. We rented out this old house, which is built like 100 years ago. And the first floor is again, this kind of primitive creature-ish quality given to the house. This lamp is the touch sensor, and this space is three-dimensionally generated constantly. If you touch it, the ripple goes around in three-dimensional, and then when it touches with this stairish structure, it shows its ripple kind of going around. So that's it. But if you touch it, you feel like the sleeping house kind of awake, and then what are you doing? What are you doing here? And then I'm sleeping. Kind of that you feel some kind of quality of the building is trying to be awake or something. So that's the hapticness is something we tried in here. And then the second floor, it's more interesting because this is the old house. And if you go up the stair, you feel that the building squeak, and then you smell the old building and then tatami and an old wood and stuff. And there's this Fusuma and Shoji screen, there are 2 rooms. And you have to go up and then open this. And the system is very simple. There's only one projector, that's it. But this Shoji screen has a sensor. So if you open, the projection changes so that the inside could be like as if outdoor condition. And interesting thing is that what you do is go into the room, crawl into the window and open the window, sliding door. And what you get is, outside condition, and then actually there is a 3D sound. If you open it, the outdoor sound become a little bit louder. That's it. But the 80% of the people feels that when you open it, it's like sometimes that it's outside is raining before you see the shadow of the rain. But if you open it, you start hearing the sound, and then you see the rainy kind of garden outside. And 80% of the experimental people who experienced say that they feel the wind coming in or colder air blowing into the air, which is not happening. It's just the same room, and nothing is supposed to be happening. But it's our brain start generating certain things if the information is nicely coordinated. And that's the interesting kind of quality. you don't need to copy and then generate every single information, every single modality. You can do some critical thing, and you can take advantage of the surrounding physical condition, and then the rest is going to be generated in your brain, and that's actually more powerful as the experience. Recent project, we renovated this existing department house. It was a department house like this, and it was way too clean, and nobody knows that it's a department store. It's too nice and clean design. So they asked us to make it more active and dynamic. So we removed the screen. We superimposed these super huge LED screens and exposed the backside structure, which is more dynamic and vertical. And the important thing is this is the one of the building of the entire street as a shopping street. So we try to give the facial function to the entire neighborhood, not just for this building. So to make it happen, we have to make it volumetric, not just the surface. And this thing is constantly moving, and not just by the programming. This is a generative art. And also, it's unproportionally big. And then you feel the kind of awkwardness. You cannot look away from it, and you cannot noticing that it's moving. And then you cannot ignoring it. That's the effect. So it's not about the harmony. It's not about the simple beauty, but it's actually how to trigger a next action in the human's brain. That's what we try to do here. And we do very straightforward parametric and computational designs too. So also more than 10 years ago, it's in Nanto. We work with the bioarchitecture for Masana. Do they teach here anymore?
Used to.
Yeah, Mr. Core, right?
9点就是他们NOIZ 有跟9点合作，这是中心新村的什么智慧工研院的一个园区。
That's right, right. And so we designed this building, and then collaborating with them, and we have to design this external skin, so that it's kind of parametric kind of value, west and south and east and north and something, and then there's a laboratory which needs the sunlight, which doesn't like the sunlight, which needs the view, which needs privacy. There's so many different requirements, location by location, elevation by elevation. Those are parameterized, and we made into the optimization of a construction and cost and applied to this. So it's a very pure computational example. And result of it, we have reduced the construction fee quite drastically by doing it by ourselves. So it's one of the early application of it. We did the same to Shibuya in Tokyo. This building is kind of unique. It's an office building, and it's not that fashionable building. And somehow this middle portion is the AC chiller. It has to be placed in the middle of the frontal facade. We have to deal with it. AC chiller has to have the ventilation function, but at the same time, it's not very beautiful, so it has to be hidden. So we came up with and then there's a cost limitation. So we came up with the only 2 patterns of the fin, and computationally simulated and laid out so that it doesn't look like always the same. Day by day, weather by weather, and then the way you're looking at and walking around, it constantly changing the pattern of the reflection. So we are not making it anything kinetic, but your perception and circumstance passively change the dynamics. So that's what we did for here too. And this landscape pattern is also parametric. I don't know if you have already professional experience, but in this kind of building in urban condition, there is a strict code of how many percentage of ground has to be covered by green, or one high tree could be considered as a 6 square meter, blah, blah, blah. And the visibility requirement, and then, pass width requirement, so many things are required here. So those could be all combined into the certain, algorithm, and then we put the parametric value, it generates this kind of pattern, and then we just adjust a little bit, and then we get this very nicely comfortable landscape design. which has been very nicely used up to now. So it's also one of the actual successful application of parametric design in a real project. And so computational design doesn't mean that it has to be, or digital design doesn't mean that the output is digital. It could be as analog as possible. And then your generation process could be very computational. In this case, the one side, there's a particular angle that give you a rubber ducky kind of pattern. But all the rest, it looks just a junk. But you can carefully look around and find a certain position, and it's actually low D, So any form could be, trimmed, at least from the two point of view, to form the perfect outline, right? So this is something that you have, it's a teddy bear, and any of the other location, it looks like nothing, just the random amalgam of form and panels. But if you carefully look around and find it, it's a Stanford bunny, So it's computational. It's impossible to design such a thing without computer. But the output doesn't need to be computational. I mean, the digital. It could be plywood and just a scaffolding pipes. That's it. But you have to have the methodology how your data in a computer could be carefully and then accurately transformed into the construction material and location. You just need to know the process of it, which you might be very familiar with. But you have to have a code issue, you have to have a materiality cost, and everything combined. That's the balance that you have to have as the computational designer in implementation. But with that correctly and carefully applied, then you can do something like this with the new kind of surprise with the low budget. So that's something that is very practical. In this case, all the explanation is like this, so everyone starts complaining that it's hard to find the right explanation, but it's kind of fun because they have to move their body and find their location. Hey, how can I lead this? How can I get this thing? So actually, the digitality requires you more of the body involvement, action involvement than normal. That's actually a value. And we have quite a few exhibitions and interior projects too. This is also in Taipei, Bonchu, Beisu Meisukan. Yeah. It's a building was there when we get there. So they asked us to do some external decoration to attract more people because this building is unique. The entire northern facade is entirely glass. So museum normally doesn't like the natural light because the UV destroy the artwork sometimes. But this is more urban kind of condition, so it's more like a display window to the city. So we have to give them more active, presence. So we did this, exterior, and then also the interior furniture is all like a wireframe. It's as if it's like a 3D, rhino screen. But you walk in and you feel like you're in a rhino space and stuff. So that's an illusion. It's actually very functional. It's very comfortable to use this chair. And then we've been doing like up to 15 exhibitions for them. These are one of them. There's one of them, and one of them. So etc. And we do some office spaces. This is the digital company in Akihabara. Their request is want to appear as digital as possible, as techy as possible, as futuristic as possible. So we just give them a futuristic presence. This is the unique film. It changes the color depend on the angle that you look at. So to enhance the quality, we create the curvy wall and apply the film, that's it. And to enhance the effect, we put the crisscross line lighting on the ceiling so that the distortion and as you move around is going to be more enhanced, not on top of the color change. See, so this is what it is. Also, and then we do quite a lot of creative commons, creative hub for a large corporate. This is the NTT, and the kind of unorthodox angle and an unorthodox corner condition and an unorthodox kickboard condition, so that they can experiment so many issues, and they can mix different departments within the company or external agents too. And this, for instance, this round kickboard is practically designed so that they can test autonomous vehicles in here. And if you, I guess that you might have some experience. If you want to run the autonomous mobility over here, they have to have a sensor, right? And those sensors are really bad to detect the glass. They might easily run into the glass, and they want to test it, and they have to experiment that kind of quality. But of course, we don't want them to kind of crash into the glass. So this, curved kickboard gently kicks them away from the glass so that they wouldn't go into, even though they cannot detect the glass. So some of those quality, if you carefully, explore the possibility, that could give us the hint for actual design too. It's a Sony creative lounge in the basement, and the disc design is try to be unconventional but still functional and flexible and inspirational, so that they could generate any kind of combo. You can extend as much, and you can combine into the kind of group session kind of stuff, and also the stairs, so that they could be more, frankly and a friendly atmosphere could be generated. And the local and materiality, we don't not just deal with the digitality and then kind of computational. We of course deal with the local and material kind of architectural aspect too. This is a hotel in Kiyamachi, Kyoto. It's a simple design, and the box and flat roof, box and a flat loop, and a box and a flat loop, just 5 layers of those. That's it. And Kyoto has a very strict rule that every single building has to have the canopy like this, so that they can accommodate the traditional townscape. So we have to take advantage of it, and we want to make it not copy of a traditional building, but we want to enhance the contemporary quality, but we have to go with the those kind of requirements, and then that limitation give us the certain kind of a creative inspiration inside. Everything is not traditional, but you can take advantage of the surroundings so that you can still feel that you're in Kyoto. Similar approach to the house in California. This is also a simple wood block stuck into each other, and the angle is intentionally different so that you can feel more different quality based on the different layer and different angle. This is what it is. And this is a sunroom for the client's little kids. And the verticality, it's actually 4 layers, but you can have the natural light into the basement too. Right? And this is an ongoing project in Tokyo, Japan. Miyota is a little bit away from Karuizawa, which is the typical mountain summer resort area. And it's actually very much of a trend in Japan. A high-end villa could be shared by the membership, so that you can use any high-end villa anywhere in Japan if you're a member to certain days, so like 30 days per year or something. This is one of it. But somehow our client is a little bit too greedy to be high-end. So they want to pack as many villas as possible in this land, so which is not very high-end. But they want to make it high-end, but as packed as possible, which is very contradictory. So we came up with this concept: just draw the curvy wall, and that defines your privacy, and that gives you a structure. And the composition is just a curvy wall and a flat roof on top of it. That's it. But it gives you a completely different sequence, different room structure, different composition sequence. And so each house could be unique, but very simple. And the angle is carefully, laid out so that no angle could overlap each other. And the inside of this curve, it's going to be completely, protected from their privacy. So you can be naked in a courtyard. You can be as relaxed as possible. And the bathroom outside, and if you can go out with naked, after sauna or something, nobody's going to bother you, even though your neighbor is right behind the wall. So there are some, and then the nice thing is this curve is something that we use a grasshopper and give them a physicality and a certain kind of code restriction and structural restriction. And so we just roughly draw something like this, and then they're going to adjust it so that it's going to be feasible for construction point of view, building code point of view, etc., etc. So this is actually some good example of generating this kind of shape without having, too complex process of design. This is a small house in suburban Tokyo. It's super cheap house, and it's nicely designed. It's a nice house by itself. But the challenge of this house is not just the design and cost, but the methodology. We use the whole design process only with the game engine, in this case Unity. We didn't use any BIM nor CAD, architectural digital tool, so that we can try the materiality, lighting, and then like furniture, etc. It's so much easier with the game engine. And nice thing is it's very head mount friendly. So the client who could be not familiar with the drawings and the sections, they cannot imagine the spatial kind of quality, but they can experience exact sense of the space, the size of the scale of the space, and that's a benefit. But that's a typical kind of benefit of using a game engine or using a head mount display. But our aim of this trial is the fact that the building, once the building is completed, you're gonna automatically get the game engine data, which is exactly the same as the build condition. And that means that once the building is done, your kid might be able to kind of upload your house data and to the Fortnite, and then hey, let's come up with my house and let's play it tonight, and then they can shoot each other and then kill each other, whatever survival battle could be done. Or they can invite physically your friend, and your game engine data is exactly overlapping your condition, so you can do the zombie game or something. It's a small house, so maybe it's not big enough, but that's the benefit. You might design BIM, CAD, any kind of architecture digital format, which is only used for architecture construction. No other industry use those. It's not edible for them. It's useless for them. Then why don't we change to design process, the design process into the game engine, which is more edible and useful for the other industry, that's gonna give more value to the architecture, building, and data. And this is the example, and it was very successful, even though unfortunately, this client doesn't play game. It's not useful, but if, let's say, Taipei Station is entirely game engine, the Taipei Dome is, or anything, this whole thing is game engine, and that's actually a whole new world. And even more, architecture as an event. We don't necessarily need to design a physical condition. This is the Shibuya CAS building that I earlier shown it, and we have 3D data apparently. And they ask us to design winter illumination physically. And we step forward, we design the winter illumination decoration, and you can see these 4 the balls. These are the flight machine. And you can go into the virtual space. You can do air race, we call it air race Shibuya, air race. And you can call for your friend, and you can get into those 4 machines, and you can do the competition around this building, which is nice because you don't need to go to Shibuya. So anyone on this planet is capable to do this, visit this building and then play this game. So it's nice that because somebody from Argentina or someone from South Africa, France, Czech, anything, they play this, and it's kind of, they like it. It's a nice thing. And so you can extend the accessibility through the virtual condition. But something better than that is, again, we actually designed a physical winter illumination too. And those winter illumination could be designed to be a AR trigger. And you can call for your data of your race, and you can watch your race at the real site again. So it's twice or three times other, variation of way to enjoy your event and experience. You can share this kind of thing, and you can go to there and you can enjoy it again in different format, different point of view, different kind of status. So this is how we try to merge the digitality and the physicality into the extra value. Digital is digital, physical is physical, separated. That's kind of waste of the opportunity. How you can combine those two, taking advantage of the position being an architect, there's so many more variation and then possibility. And after that, somehow the real air race pilot saw it, and he came to me, hey, can I fly with it? And then he liked it. And he's been saying that, I don't know if you know, last night, but 2 nights ago, there's a final Grand Prix of the Formula One for this year in Abu Dhabi. And there is the air race, Red Bull air race up to 2019. It's a Formula One in the air, which has been going around physically in different cities in the world. And it stopped because of the COVID, but the final year, 2019, the grand champion was a Japanese pilot. His name is Yoshihide Moroya. And he came to me, oh, I've been dreaming of reviving the air race like this kind of form. Can we do it? And then we discuss, and we figure out that they have this sensor that they can take, extract the flight data super precisely, and the super precise kind of frequency. And then we are able to apply the same thing. So eventually, this is what we did. In Tokyo, in Japan, there is the open data of the urban 3D data. All the building is 3D data, and we can freely use it. And so we create the flyable course in the middle of Shibuya, and we distribute the data to the 8 pilot team all over the world. And they use that data to physically fly in their base airport. And they extract their data, and we collect it, and we override, and synchronize. And we call for the semi-final and then final on the same day, one day and one particular time. And we make the event. And everyone, let's say 3 o'clock is the final race. And you open the application and see whatever, the iPhone and then the head-mount display, the race start. And anyone in Shibuya can see this race in the same location, same relationship to the city. And that's the kind of AR is potential. I mean, currently, you can join the AR event from your group, but you are physically alone. So you cannot really share the excitement of the sports event or concert. That's the limitation at this moment. But in this case, in fact, there's hundreds of people gather in Shibuya, and they cheer, and then they cheer, hey, go on, and that kind of excitement is there. And there is this 3D sound around you, so that if the flight is coming over, you hear the sound is around you, and the associated with the sound and the location of the information of visual information. And we kind of took it further. And this year, because of the expo and because of the huge development just opened in Osaka, we took advantage both. In 2 locations in Osaka, we held the same thing. So this year, the challenge is, it's a air race Grand Prix in Osaka, but we have 2 venues, basically 2 venues. But 2 venues, there are 2 data, and that could be combined into one. So that the Umeda Station area, which is this, and the Expo area, which is another one. So Expo area has the Umeda buildings, and the Umeda building has the Expo ring, and they experience the race exactly the same time and exactly the same relationship to the urban condition. something like this. We overlay the wooden ring and superimpose into in the Umeda station area. So this is what it is. In this case, more than 10,000 people experienced it, and then we had the 3D sound, and then unfortunately this movie doesn't have a sound, but everyone looking at it. And nice thing is there's a building data, so that occlusion is also happening. If the airplane goes behind the building, it just disappears and then appears on the other side. So, and then it doesn't matter where you're looking at, it becomes the same way, because the relationship where you are, where the airplane is supposed to be, and the building is always guaranteed in the kind of condition. So this is the view in the expo site. You see the buildings from Umeda Station, which doesn't exist in the expo site, but anyone in the expo site can experience this thing, regardless where you are. And also that's the spatial synchronization and the temporal synchronization. So that's something that you can bind different events in the same location without having only relying on physicality. So expansion. And it's nice because apparently in a real life, 2 airplanes do the time attack at the same time. It's way too dangerous. It's not possible. But you can do it in this fashion. And we've been doing it for years now. And the pilots, especially younger pilots, their technique became so much faster, better, because they see it. So that the better pilot, at what timing, what kind of angle they can pull up, and then they make a turn and stuff is more visible, so they can copy and learn than the orthodox method. And this is how it appears. There is a 3D sound, so you hear the kind of thing, but if you don't know what's going on, because there's no ring, there's no airplane, or it's just a sound. But everyone is looking at the sky in the same synchronized fashion. Everyone is following the airplane. So it's a very awkward situation, but it's nice thing is really everyone got excited. It was a huge sound of the final, and then everyone is very chilling and then clapping. So it's a very interesting kind of unique experience. So maybe that I'm gonna move into the second half. Are you okay? Is it too tired? Okay. The important thing is the physicality, and the main topic of this lecture is the physicality and digitality, right? And the object or the venue place, the physical place, physical object is still great because they can combine infinite amount of information and they never bug or go crazy. If this mouse is always mouse, once it's mouse, it never all of a sudden becomes an apple or a gold or something. The mouse is mouse. And within this one tiny physical mouse, there's infinite amount of information. You cannot extract all the information digitally. It's impossible because there's so many synchronized and then synthesized and then, hybrid information you can create out of it. So the one tiny physical object has always the infinite amount of information, right? Whereas what we can extract as the digital data is super limited, maybe the shape of it and the movement of it and the material, color, certain things. But maybe you can count, maybe 10 layer, 20 layer of information, that's it. And those something that you can extract and then transfer and then share with somebody and communicate and then edit. And so reality has the infinite amount of information, which is impossible to take. But we can, even though you can only extract maybe 10 layers of information, the fact that you can extract, extend, and edit, and then recompose is a super interesting and a super valuable thing. So there's so many arguments that the digitality is not enough. And you expected that everything can be possible in the digital something. And some people criticize, hey, this digital kind of technology can only do this, and they cannot even do such a simple thing. It's a bullshit because that's the reality. But even 3 layer, for instance, that old house, we just do the projection, we just do the 3D sound, and you do the shoji screen. That's it. But you can generate the other information in your brain. That's the value. So limitation of the extension is something that you don't need to look down on, but you have to be very careful. What kind of layer and what kind of layer could be combined with what kind of situation? That's the value. So we have to be more careful and then experience more, so that the expanded experience on the bottom, it's a shallow layer, but you can extract off the limit. That's the value. And then also enhanced experience. That might be only possible to, on top of it, taking advantage of this physical presence, and then maybe sunflower coming up, then becomes the Pokemon, something, whatever is fine. But you can add some layer in this location. So that could be enhanced experience. So either one of it, it's not like you can do both. But within this limitation, there's a countless amount of combination of possibility. So we shouldn't just, swamp between digital and physical, kind of a simple binary kind of contrast. But we have to have the higher resolution. What kind of layer, what kind of information could be effective in certain conditions, certain purposes, certain experience and stuff. So there's so many more. And again, the main thing is common ground. Maybe you can start getting some kind of, concept, but this is the basic diagram that I use to explain it. It's a quadrant diagram. The x-axis is physicality and digitality, and the y-axis is agent or environment. Agent could be a point, and the environment is a box around you. And then up to 20th century, we've been living in the left-hand side of this. Physical agent as a human object animal as a physical agent, and the architecture, city, nature as a physical environment. Our society, our economy has been done in this left-hand side up to the 20th century. But now we start having this mid-right, bottom right, digital agent. We call it non-human agent. But they could be autonomous mobility, robot, AR, avatar, VR character, whatever it is, physical, digital, and then the AI controlled and then remote control, whatever it is. They are still having a hard time to understand the physical environment. That's a limitation. So to make it happen, for them to behave more in the physical condition, we have to introduce the upper right, digital environment, which you can call digital twin. The humans has to prepare a digital twin of the physical environment so that the digital agent can read it, because they cannot read the physical condition. So the digital twin could be carefully prepared so that that is exactly matching with the physical condition. And then digital agent read the digital environment, and that guarantees the digital agent is as if moving against the physical condition, but it's actually not the case. The problem is digital agent could be hundreds of different ways. Again, the perception of the circumstance differs species by species. Insect, rabbit, human perceive the circumstance completely different way, because the ear, eye, nose, everything is different, right? So it applies to the robots and any kind of digital agent. Their sensor is different, their description system is different. So that means a digital twin needs to be different, right? So if there's 100 different type of the service in this market, you have to have hundreds of different digital twin. That's a disaster, because you have to do the API coordination and all that, the endless amount. Day by day it's updated. It's completely impossible. Then why don't we have a certain common language of spatial description, which is edible for majority of the digital agent, and it's possible. That's called common ground, right? So in a way, the common ground is a cognitive space description for non-human agent. That's the fundamental kind of concept. In a way, we're gonna give a human right to non-human agent. That's something that you can turn into a more humanistic point of view. It's kind of awkward, but the barrier freeness is something that you have to be very aware of to design a building in an urban condition. That is the physical challenge of the human body, wheelchair, blindness, and stuff. But NHA has even more challenge than human. And they have hard time to move around and perceive the circumstance or in physical circumstances. Why don't we design a house, urban condition, street, more friendly to non-human agent? Why not? As if they have a human right? And then eventually, through the non-human agent, certain people might benefit. For instance, there might be some kid who's been hospitalized years. They are not able to go to the school. Maybe they can take advantage of the robot in the classroom. They can move around. They can see the blackboard and raise a hand, raise a question. They might be able to have the school social life with your friend through the non-human agent. If that's the case, looking at the human right onto the robot is the indirect human right issue. Then designing a classroom robot-friendly, non-human agent-friendly, is certain way a human right issue. So human right issue is no more just an issue to the actual human. How to design a robot-friendly, virtual-friendly, description-friendly, the physical environment is already becoming the indirect human right issue. So the common ground is to enhance and extend that concept into those in-between field. Another description or explanation of the common ground. Importance of the scale, the sense of a scale, to consider the the digital spatial description, not just only for the spatial scale, but the temporal time scale too. That's important. The x-axis is spatial scale, and then y-axis is temporal scale. GIS, which is, let's say, Google Earth, and then the the urban condition, is the one type of the spatial description. They deal with the biggest layer, and BIM and CAD as a smaller scale, but still deal with the big scale, like a building and stuff, right? And both GIS, which is map, 3D map, and BIM CAD, which is the architecture, those are drawings and map. So they're designed to be static. They cannot be dynamic because the drawing changes minute by minute. That's going to be disaster. So it has to be static, right? So they don't have the ability to deal with the temporal change, dynamics and animation. Whereas the gray hatch is the scale the human normally use, and to let the non-human agent to communicate with human, they need to deal with this cross section. But surprisingly, there is no spatial description system which is designed for this portion. But game engine is designed to deal with this portion, but the game engine is designed only for virtual spaces. They are not designed for physical spaces. Then why don't we take advantage of the existing technology, amazing technology as game engine, and let them perform in a physical space? And that's the basic concept of common ground. To make it happen, game engine is isolated in a virtual space. So we have to give them eye and the hand. So input and output methodology for game engine, and those combination is the basic concept of a common ground. In a way that lead us to a concept, kind of understanding of a potential value of separation of sensing, calibration, or actuation. Same. The game engine deal with the calibration layer, but they don't have the sensing ability to the physical space, and they don't have the actuation, put the output into the physical space. So we have to separate those and make it friendly to the game engine. And sensing could be camera or the microphone, temperature, whatever sensor you use. And that could be connected to the game engine. They're going to do the world simulation, simultaneous simulation. And their information could be captured into the robot arm and then any kind of actuator. That's their hand, right? So this cycle could be used, and then game engine that let's say monsters, they are not looking at you from their eye because the game can capture all the movement without using their body, right? So the game is already a system. The sensing, calibration, actuation is not compact with the one body. Whereas we tend to think that all those three has to be in one solid body because the human is like that. But the game engine doesn't need to have such a limitation, and why don't we take advantage of it? That is, in more social point of view, actor, processor, and then beneficiality could be different. The wheelchair might be moving around, but they don't need to have the camera. The camera could be in a room. That might be more efficient. And the professor doesn't need to be on a wheelchair, and that could be somewhere in the storage. And beneficiality is the machine or somebody using it. And then the wheelchair could be much, much cheaper and much more applicable anywhere. And then that's benefit for the society, right? So the nice thing is that the human, virtual agent, physical agent, everything combined. If instead of letting each agent as powerful and as functional as possible, but environment intertwine all those recognition and calibration and actuation, and so that they can share those functions, that make it more fluid, smooth, and cheap and easy to make everyone more functional. That's the basic direction. For instance, this is the condition that we experienced like 3-4 years ago. It's our laboratory in Tokyo. And what we're doing is the sensor is all on the circumstance, environment side. And they are sensing their movement with their bone structure, and then they're overlaid onto the people in Tokyo. And there are some avatars, which is avatar alone, right? And those are the people from Osaka, and they are seeing each other in this relationship, each other, and there is a 4D sound each other. So that somebody is talking to you from behind you, and you hear it, and you talk to them, somebody, hey, you, and then they can sense this person is talking, that person. You is something valuable, which is not possible in the Zoom communication, right? And the Osaka people is doing something, and Tokyo people is copying it. So this kind of interaction through the space is possible to apply. And this is what they're doing. Sorry, can I? Sorry. Let me to the bathroom too.
Okay. Yes, no problem.
Okay. Where's the bathroom?
Oh, over there.
Sorry. Excuse me. Sorry for the interruption.
No problem.
So this is what we're doing, the sensor fusion. If you have a sensor, you might be experiencing something like this. So the one sensor is gonna capture 4 or 5 people, and then some might be in a dead angle so that you cannot see. But if you have a multiple sensor that you can see the more of the multi-angle so that you're not gonna have a dead angle. But you have to have a fusion because the 3 sensors separately capture same person. So you have to have the merger of one ID into one description. So it's a constant optimization of one body into one data, even though they see a number of information of the amount of a sensor, right? So that the ID continuity of the physicality, the spatial continuity and temporal continuity is very important to do this kind of a generalization of the spatial description. So the nice thing is that there's a multiple sensor so that they can take, in theory, infinite amount of human data. Something really stick into the deep side of my nose.
Okay.
I don't know. No, it's been kind of dry. I think there's something physically sticking to the deep side of my nose. Anyways.
And those become very sensitive.
Yeah, I think the hotel was too dry, and then something, I can't get rid of it. Anyway, sorry, excuse me. It's a technical term that the sensor could be different, and the communication method could be different, and the application could be different. That for instance, we did it in an expo. If you make it in service in the current condition, you have to have a sensor and communication application in one package, and you have to distribute a certain amount to make it more business feasible. That's a huge investment. But what we're trying to do as a common ground is the nice gateways in the middle. So sensor fusion could be independent, as many different systems could be there, and each one could be very small amount. And communication platform application, those could be independent. It doesn't need to be a whole package initially. And then they can do the ecosystem, so anyone can join this ecosystem without going to the huge amount of the platform, so that that it's more ecosystem-based kind of condition is applicable with the gateway. So our laboratory is trying to develop this gateway as a unified condition of any kind of body description and the real-time distribution. Nice thing is this is the unified description system because any single sensors using a different type of the body structure kind of description system now. So we unify it, and then the spatial data could be accumulated as the form that they could be all uniform, and that's gonna hit a certain amount, and that could be applicable for AI. So large behavior model is only possible with this kind of ecosystem. At this moment, there's a LLM or whatever is text-based, and there's a humongous amount of information on the internet with the text-based. But let's say your posture at this moment, your movement, your interaction, that is never be described, and so it's not digitalized. That's not something AI readable now. But with this kind of condition, your movement is going to be digitalized. Basically, this is the platform that filter all the information, behavior information, interaction information. Eventually, that becomes the territory that AI can read and learn. So this is the true value of the system is the large behavior model. And this is what I talk about. Once this is possible, it doesn't need to be limited to the human movement, and that could be applied to the autonomous driving system or robots. this is what I exactly talk about. The wheelchair, electrical wheelchair, without having any sensor or computer, any kind of equipment, can do the autonomous driving, just giving the start and the goal point. Because the sensor is not on the environment side, and calculation power is on the environment side. They can sense the robot, they can sense the human movement, they can sense any kind of object in the middle, they can constantly change their path so that this machine is so dumb and cheap, they can do the autonomous driving. And nice thing about this is that if you have the two different systems, like company A's robot and company B's robot, company C's robot, their slum system are normally different. They can communicate each other. But in this case, the environment guarantees how to maneuver with the other service and human. So you don't need to worry about the kind of coordination with the other system. So the space is the intermediate kind of environment for different systems, so that once this kind of system application to the society become more complex, this kind of the space common ground environment is going to be more necessary. This is exactly the same condition of the experiment. This is the actual video of the same live simulation. You could see the blue column, those are the human, so that you can see that they are trying to adjust their path real time. And then again, this guy has no sensor, no computer, they have the communication power, that's it. So common ground that is now broken into the 5 phases, started as a cognitive spatial system, now moving to the phase 2, which is a behavior spatial overlay. And the phase 3 is a physical NHA integration into the same system. And that number 2 and the phase 2 and the phase 3 combined could prepare a stage for large behavior model application to the society. That's gonna lead us to the application of a spatial AI implementation. In this case, spatial AI is not the AI to understand the space, but the AI inhabited into the space. So LLM to LBM might be the potential transform, and that architecture and the common ground integration might be the key to make it happen. And recently I've been kind of interested in the cognitive science, and that's that explained that how important this transition is. Let's say the cognition of human being it's a philosophical term to scientific term. Up to now, what we think about the cognition is pretty much the symbol cognition, which is text or sound or movie or anything that you see and understand through the information, so that we call information. But that's not going to be enough to form a real vivid understanding, cognition, to form in your brain. Recently, that the embodied cognition and active cognition is said that it's very indispensable information. The sensing and the cognition is not just the, let's say, what we call 5 senses, vision and smell and then hearing and stuff. But we have so many other things like organ sensing and muscle sensing, balancing and everything. So the body, having a body is very important, and doing the action to acquire certain information is very important to make it more rigid in the body and then together. So that let's say Zoom conference often say that it's never be somehow enough, and Zoom class doesn't give you that much of an understanding impression. That is because the Zoom is only a symbol cognition based communication, whereas common ground condition gonna force you to have a body embodiment and force you to have an active. So the communication, like satisfaction, is completely different. It's hard to explain, but if you experience it, you sense it. So embodied in an active AI is something that we have to go for, and that needs a space, and that needs a physical space. and that needs the physical space to be cognitive and sensing and agentificated, right? The space be able to sense and calculate and actuate is something that you need to achieve this stage, and human and NHA can interact more smoothly and through the environment. So agentification of a building, agentification of the city is something important, and that's something that are on the hand of the architects. That's why we try to kind of achieve. Common ground is a pragmatic approach to the society with the spatial AI. That's the ultimate goal. That's what we do at the University of Tokyo, our laboratory. If you have any chance to come visit and then collaborate, you're very welcome. And toward the end, we designed the Architectural Informatics Society beer. It's completely jump of the topic. That's something that, the Professor Ho, Professor Ikeda, we are collaborating. We're going to have a year-end party next week. And we designed the AIS, IPA, and Weizen Pilsner. And we are hiring. So if you are interested in working, please let us know. Thank you very much.
So the second part of the topic of the lecture probably is a little bit far away than what you are doing right now at school, but not that far actually, because the very near future, like Ikeda-san and Toyoda-san, some researchers, many of us actually already delved into this realm. And what is happening, but I think there's a gap, and also it's an opportunity for everyone here, that if you can see some interest from this, actually that will be the next big thing, I would say, to the architectural profession. I just in Mandarin just say that this good. 刚刚那个柯达老师讲的那一些，因为后半部其实是一个发展中，还正在开启的一个领域。那这个领域，老师，我各位刚刚看那后来讲的东西啊，跟一般我们在现在举例的 AI 跟机器，像我提到这些东西，其实我这些的想法，不会是工程的人去想。这些对是在像重视空间经验的，像建筑的人，或对于体验、对于人跟体验的关系，这种比较偏重从人类主体性去想的，是这样的人会特别去关注。所以刚刚有提到一些那个断裂的地方，就像刚刚讲视讯会议的这种断裂感，就是因为你接收只是视觉符号的东西，你跟你的身体经验是没有连接。所以有时候会觉得，虽然视讯会议好像很方便，但是对我们来讲都不是属于印象深刻的东西，你没有办法建立那个连接。所以你现在如果回想你过去所谓参与的任何一场视讯会议，都没有太多有印象深刻的。但是如果你有实体会议，纵使只是某一个同学今天开了个玩笑，或在会议里面，因为有那种很完整的空间体验跟身体经验，那个所有事情它是串在一起的。你对这个事情会经验特别的印象深刻，所以他就提到我们现在讲的那种记忆啊，什么 AI 那种知跟这种智慧、空间智慧上的事情，如果少了这些东西，上就少了非常多的连接。那至于我们要怎么去切入，就是刚那个多大老师有提到，建筑物啦、空间啦，这些反而是很重要的资讯的载体。就是你的所有感知其实都来自于这些环境，它传递到你身上。怎么样把空间变成一个载体？那这些载体就不是只有像过去我们讲说全部变数位化，不是只有这样，就是说它那个叫实体的 material 那些事情很重要。所有你营造出来的东西都是可能都是未来，也就是未来的资讯学，它不会是只有在谈0与1啦。未来资讯学在谈的是所有实体跟虚的所有的事情，怎么去把它串在一起的那件事情。 那一方面它也很大，二方面就是我觉得它有很大的这个发展的潜力，因为不管从论述性啊，从未来你怎么去整合这些事情。那像刚才那个多达老师举的那些例子，老实说，你仔细想，里面的技术都不是非常先进的科技，对吧？就是它单独看科技的话，都不是很就独立来说不是先进，但是它用一种很特别的方式去整合，它会最重要是串联起人的体验跟经验跟记忆跟所有的事情。那这种事情谁有办法做？你绝对不能期待工程领域的人去做，他们不是去想这种事情的人。但是我们这个领域的人，老实说，跟刚刚讲的又有点距离，因为我们各位校现在可能没有那么多经验专门去处理这样子，没有那么多对于像技术如何运用在真实环境的，所以意思说中间我们还有蛮多的可以去接触、去学，以及怎么样把那东西可以纳到你们的这各种未来可能的设计上面。但技术上其实也不用太担心，因为像所有团队，周导老师他们都有很多技术团队一起参与嘛，也会找很多工程的人或者一起参与，只是说中间需要有一个人能够想出这样的事情，能够去运筹帷幄。老实说，这就是建筑师在干的事情啊，就是我们要去想所有事情怎么样把它兜在一起。但你们要很有 sense 嘛，但所谓的 sense 就是不能完全不知道，但起码你要对这东西去接触多了解啊，就是你去想想到底缺的是什么，而不是被像媒体或者是工程或各种那种太过于渲染式的报道的去带着你牵着鼻子走，而是回过头来想说，按我们的从建筑本位的角度，我们的任务是在以空间为媒介，串联起人跟体验跟未来生活的品质各类事情，那我到里面可以做什么事情 ？Yeah, I just literally just elaborate certain things that in your slide. Yeah. So yeah, maybe we can open for question. Anyone you got any curiosity or any you're looking for jobs, seeking opportunity, yeah, feel free to ask. 有什么问题，任何问题都可以，好奇的或者都可以问。
Professor, thank you for your insightful presentation. I have two questions. My first question concerns the definition and impact of digital architecture. From the case you share, we see the diversity of digital architecture in both design and application. Today, the scope of digital architecture seems to go far beyond form and tool. How would you define its core scope? More importantly, as a medium, what is its tangible impact on human daily life? Beyond convenience and or novel experience, could it fundamentally reshape the relationship between us and space, information, and even each other?
Thank you, and a very fundamental question. I think that I have to ask you to rerun the whole lecture. But of course, conventional architecture design, our methodology only limited to the formal language. So our drawing has the dimension, the shape, and the additional information, material, manufacturer and stuff. That was the only combination. But now, again, we have so many other information we can extract and edit and recombine, and that's the value. And the channel is becoming more and more available. So that definitely is changing, and we shouldn't be limited to the conventional methodology and then path of a drawing and then dimension and form. And that's definitely changing our relationship to the profession and the value and social value and economic value and the space to the space and the space to the human communication method. Again, let's say what I show is something, it was limited to the human communication before, but now, even though it's limited, that you can communicate somebody on the other side of the planet in a very mutual fashion, interactive fashion, that changing the value and then your belonging and who you are and stuff. So yeah, it is significant and enormous possibility of changing it. It's not something you can go back. That's what I think.
And my second question is following the idea of the perception you mentioned. You noted that all things perceive information and signal differently. And this makes me wonder, could digital technology serve as the sensory tool that expand the dimensions of human perception? If we view architecture as an interface for such argument perception, how could a platform like Common Ground apply this compatibility concerns in our daily life? For example, helping us perceive urban dynamic, environmental changes, or social content that are otherwise invisible to us.
How could you come up with such a fundamental question and then still reading? You making notes. Why? It's a very fundamental question. I don't know. You already mentioned what I would like to say, so it's what it is. And then the also answer is I don't have an answer yet. We just start scratching the surface of this territory. We don't know what's the format. Where, for instance, the common ground, even though we strategically limit into the body structure, that kind of a 32 control point of the body, and we are not dealing with anything else. But within that, there's a diversity, different service by service, and we cannot even combine into the kind of absolute, standard format. And that's very important, and it's gonna be keep changing and adding some like a facial expression and let's say pressure information. How to compatible with this kind of different territory is already a challenge. So it's going to be endless challenge and endless coordination. But through this experiment, we are quite sure that there are certain territory which could be combined and very valuable for multiple field, which is efficient and economical to merge into the certain standard format. It's not going to cover everything. But we have to always constantly finding certain kind of midpoint, which emerges by itself. So we have to be, free and open to see and feel. It's kind of like a Bruce Lee kind of thing. Just feel it. But you have to have that sensibility. So that's what I feel.
Thank you.
I think that one of the suggestions I can also, I'm just reflecting to the same question that one suggestion is to everyone that we can actually in the training in architecture school, to be honest, we are mostly all the subject you're studying, or most of them are like a very conventional subject. The purpose for you to take the architect exam, to pass the exam, you get the architect license. But that we have to agree that these are all very conventional, standards in this world, right? But on the other hand, there are architects there are like challenging the frontier of how we want to live and what kind of lifestyle we want to have, and even we have some dreams that will never become true in 100 years. To asking a big question. But fortunately, probably that's far ahead, but fortunately we still have some projects, some new things happening, like for the Osaka's Expo, and we have some like artistic or like experimental spatial project, or even you got a chance to collaborate with architecture firm, that you have a chance to use certain new technique and tool to do something you are dreaming about. We have some tiny, like a little bit of challenges and opportunities that you are able to practice on this. I think these are all very good chance that you must take advantage of. And then from time to time, you have chance to participate with certain teams like a NOIZ team, or even there's some kind of project that is you are allowed to dream bigger and you have really can make that things happening. But you have to admit that these kind of projects are very, very difficult, and you might be like suffered from all these challenges from government, from business, from the cash flow, from all things. But you just have to know that these things always are difficult, and it's very important that you have to be optimistic in this and keep doing it. Otherwise, you will be very conservative all your life. That is really sad. Okay.
You can be conservative.
Yeah, of course, you can be conservative to be a very happy life. But from a, like, if you like to do something different, it's like you have to be consistent to your action. If you want to dream big, then you have to be brave and you have to be like fighting with different things. But if you dream conservatively, yeah, of course, your action will be conservative. That's okay. Any other questions? Something is like more like a life, how to live a good life problem.
Or anything that you don't agree. That's a bullshit kind of stuff. That's fine too.
I guess many people would say that. I mean,
Please do.
When you are in society, what this?
Yeah.
Why architects doing this?
Yeah.
It's not architect at all.
That's a typical question.
Yes,
Actually,
very typical.
Why do you need to do this? What's the value?
Come on, you're an architecture firm. Just do your job.
Yeah.
These are all these. Yeah, but in 1950s, 60s, there are many revolutions in human civilization. I mean, like humans understanding in science and in knowledge and all these new inventions. From what I know, many of them are trained as architects. They actually contribute to this new development in 1950, 1960, so much. 建筑训练很重要，但是建筑训练不一定贡献只有在建筑物，建筑的训练有时候在像1960年有很多科学领域的人，他们其实有些人是受过建筑训练的，他们会想出一些一般人想不出来的，因为他是从系统面的层次去想象的，他不是只有单纯只解决一个叫专业领域的一个小问题。尤其在那个战后那个时代，因为很多很有趣的事情发生嘛，很多刺激，很多东西就会有一些新的东西跑出来。那时候在同城的有不少是做建筑的专业。
Yeah.
Yes.
I'm very interested with the last part with the LBM. You put like sensors with extract from the agent itself and put it and like compute at the environment there, and then put the feedback of the agent to like control the agent. But my question is, if from a different point of view, is the agent itself still an agent, or is just like some kind of physical actuation from the environment? So the policy, the decision making is from the environment, which has the super large brain itself, and like how to decouple the agent itself, if the decision is made by the agent itself, and some kind of global behavior will emerge from the different agents. So will it be some kind of like better to scale up from a city scale or even bigger scale from the environment decision side?
Okay, thank you for a good question. I'm not involving the aspect of the layering structure of the different AI. because my colleague at the University of Tokyo is Yoichiro Miyake. He's the lead game AI researcher from the Square Enix. Do you play Final Fantasy? He's the behind the scene guy. He generate all the AI in the game, and our model is pretty much following the AI game. And the game AI is the one of the field that he named MSc AI. You can search Yoichiro Miyake, and there's a bunch of paper you can read through. And then he has the theory MSc AI coordination. M stands for Meta AI, and the C for character AI, and then S stands for spatial AI. So the game is the field that the character AI, your monsters and your common enemy, those are controlled by the character AI. And spatial AI generate the path and change the path, and then generate the dungeon and stuff. And Meta AI is a god to control everything. And those are different layers of AI, and they're kind of each other coordinated. And the game is amazing kind of territory that you have to design the whole space to make all those different layers of AI can perform in an optimal fashion. So they have a knowledge and skills and a structure. And in real life, there's more layer of AIs, the agent AI, spatial AI, and character AI, and then room AI, building AI, campus AI, and society AI. And each takes care of a certain area. But there's no one absolute layer, the environmental AI and an agent AI. It's more like a linear. And as I mentioned, some of the agent AI might be taking advantage of some sensor of the room AI. So there's overlap. There's no clear threshold. So it's more like how we can design a seamless kind of gradation of different AI and different kind of format. Each has its own territory kind of thing. That's my understanding, and that's what we're trying to go for.
Different layers of AI, can it be seen like one whole agent itself, and then the whole maybe the world is different composed action between interaction between these AI systems.
I can't be wrong. I mean, I can't be right or wrong or anything. My personal opinion is there's no such an absolute one, like environmental AI is possible. It's going to be conflict in each other. So it's going to always constantly form the complex system by itself, even though AI is the human generation. But that generate the kind of ecosystem which conflict each other, and then they can adjust each other. But no one can be dominant. And so in that sense, I don't think there is the, like say, Blade Runner or that kind of a dystopia sci-fi kind of, grand AI kind of cover and then control everything in the planet. I don't think it's possible because each other is kind of conflicting each other.
Any other question? Okay. Okay, good.
Okay.
Okay, thank you. I would like to thank Toyoda-san.
Thank you very much.
Yeah. So, you want to take a photo? Yeah. Okay. You want to?
And then this is the NOIZ cap and the NOIZ sticker. So if I brought some NOIZ sticker,
Oh,
please,
sticker?
please, yeah, please use it.
Okay.
Yeah. It's called marketing. Yeah. Okay. Oh, from this side?
We just take photo from.
Sure. Aren't you getting the light in right in a?
It's fine. Yeah. Okay. Yes. 后面的哦，要让脸看到哦。
三，一二三，要摆个动作。
OK。
一二三，一二三。
Something is sticking into the deep side of my nose. It's so annoying.
Oh, okay.
Thank you.
Okay. Thank you.
谢谢。
谢谢，谢谢。
Thank you. Thank you very much.
Thank you, thank you.
You don't know Professor Miyake? No.
Miyake, no.
I think you should know him. He's the
Also in Tokyo?
yeah, he's my colleague. I mean, we run the laboratory together.
Oh, in
My laboratory.
ISS?
Yeah.
Cool.
He's he's one of the lead game AI.
Oh, okay.
Okay. We have our own English name.
Wow. Okay. Okay. So it can be very easily to check his information on the website. Okay. Great. Awesome.